Hello. In this video, I'm going to show the distributed architecture used within the NewsReader European project for event mining. The main goal of the NewsReader project is to identify what happened to whom, when, and where in millions of news articles. Extracted information is stored in a structured database so that precise search can be carried out over immense amount of data. NewsReader processes event mining at a large scale, extracting events from literally millions of documents. Besides, the system has to analyze news information as soon as it arrives in a timely manner. This is a picture of the overall NewsReader architecture. In this presentation, we will focus on the event extraction pipeline as depicted in the top part of the figure. NewsReader uses a complex set of NLP modules to accomplish its task. In the case of English, nowadays there exist 19 modules that perform NLP tasks, which range from basic tokenization to name entity recognition and disambiguation, semantic row labeling, identifying time expressions, etc. The goal of the distributed processing is to analyze and implement alternatives for dealing with large volumes of data. Having a set of NLP processors, as those mentioned previously, we want to execute them as efficient as possible using a distributed environment. In particular, we don't touch the modules nor re-implement them using new paradigms. The only requisite we impose to the modules is that of using and consuming NAF documents and producing annotations following NAF. Within the NewsReader project, we have implemented two alternative architectures for distributed processing. The batch approach is focused on scenarios where a large set of documents is already available, and we need to process them in the whole batch in one go. In the streaming approach, documents may arrive at any moment, and we need to ingest them as soon as possible. For the batch processing setting, we implemented an architecture based on Hadoop, which allows distributed processing of large datasets in a cluster. More specifically, we used the cascading tool, which supports complex workflows and don't require modules to adapt to any specific paradigm, such as MapReduce. Using this batch setting, during the project, we processed 2.5 million of documents using a cluster comprised of 86 nodes. Documents took about 4.5 minutes on average, which allowed us to process more or less 327 documents per day using a relatively small cluster. If we were able to deploy the pipeline on a large cluster, we could process up to 145,000 documents per day. This slide presents the architecture for the streaming processing. The system is composed by many virtual machines, which can be deployed among different physical machines. There are two types of virtual machines. One boast node, which is the main entry point for the documents. That is, users send documents to the boast machine. The boast machine contains one input queue for storing input documents and one output queue where fully processed documents are stored. It also contains all the software used to orchestrate all the work to be performed in the distributed cluster. And then there are many worker nodes which actually perform the analysis. Worker nodes contain copies of the NLP modules used in the pipeline. When a document enters into the system, it is stored in the input queue and it waits until some worker node is ready for consuming it. When resources are available, the processing of the documents starts. We have a pipeline which comprises many stages, and a document has to pass through all these stages to be completely analyzed. Because there are many worker nodes, we can run the NLP modules in parallel, provided that there are no dependencies among them. This slide shows the different modules of the pipeline and the execution flow when executed in parallel. We have run a set of 1,000 documents to the streaming system using a cluster with one boast node and 7 worker nodes. Documents are sent randomly using a Poisson process, which stimulates the rate that documents may arrive in a real situation. The experiments show that using the streaming system, the latency is decreased by 50%. You can know more about the distributed architecture of the NewsReader project by going to the project website. The deliverable D2.3 contains all the details of the architecture.